We are going to do about data representation in the memory and how it's read and about ASCII. Okay, so we have already seen in our previous video, computer memory is only zeros and ones. So basically, it's only keeping binary digits, and you can't find anything else. Even a blank is not possible. Okay, only either a zero or one. Only the two state. So, and in our binary number system videos, we saw any binary number can, any decimal number, any our normal numbers can be represented using binary. So that means in our computer's memory, which is in this form of binary, we can store any number because you can take the decimal number, convert it to binary, and you can store it. So basically, computer will be able to handle, therefore, numbers. Okay, numbers is not an issue since it's working with binary. The base memory is all zeros and ones, and binary can represent any number. So number handling is not a issue as we can see. But how can the computer memory handle alphabets and other characters like the characters A, B, C, and D, or question marks and commas and semicolons, and there are so many characters that you see on the keyboard. So how does the computer manage this inside? Okay, that's the question we have. This particular thing is done using a coding method. Okay, how all these characters are managed in the computer is based on a certain coding method, and there are few different types of coding methods are available, but we will look at what we are actually currently concerned with, called the ASCII. Okay, it stands for American Standard Code for Information Interchange, where the ASCII comes from ASCII. Okay, so that's how this word comes. So from here onwards, I will refer to it as ASCII. Okay, ASCII code. Using the ASCII coding system only, all these alphabets and everything is managed in the computer's memory. Okay, there are other methods also, like I told you earlier, but we are concerned in ASCII only. Okay, now this is the ASCII chart or ASCII representation of those characters. These charts, there is actually a standard set, standard ASCII set plus an extended set. Okay, now the standard set actually goes from 0 to 31, and also the actual ASCII characters are based on a 7-bit binary system, but since the computer memory is handled in terms of byte, instead of 7-bit, ASCIIs now use 8 bits because 8 bits 1 byte. Okay, and the computer can handle byte by byte now. So because of that, every character will be stored inside a byte or 8 bits. Right? So the standard ASCII characters is 7 bits, so it goes from 0 to 127. This is the actual standard set, which we call ASCII standard character set. Now, and if you look at all these standard set, the leftmost bit is all 0. Can you see? Up to 127, it's 0. When you go to 128, only this will become 1. So that set is, since original ASCII was 7 bits, only up to this was actually up to 7 bits only used. So since the byte is being used in the memory, it adds a 0 in front to make it 8 bits. But the actual standard ASCII set only is 7 bits. But since 8 bits is also there, what they have done is they have added another set with 1 in front. And that set is called the extended ASCII chart. Okay, so in other words, 128 to 255, which are numbers, all the numbers which will have the 8th or the leftmost bit, this bit as 1, will be going from 128 to 255. So all those are known as the extended character set. But the issue is, if you look at the standard character set, that is 0 to 127, these are standard ones. This is how all the representation is. But from 128 to 255, those are extended ones now. So those are not standard ones. Okay, so in these extended ones, different sets of characters are there. So you can't say 128 is this particular character, 129 is this particular character, because in one mapping it will be certain characters, in another mapping it will be a different character. There are about 2 or 3 or 4 different types of mapping. So in each of these mappings, 128 to 255 will be different sets of characters. Okay, so that is why extended characters is not standard. It depends on the mapping. It can vary. 128 in one mapping can be a certain character. In another mapping, it can be a different character, and in another mapping, it can be some other character. 128 to 125, 255, all are not constant. But if you look at the standard ASCII character set from 0 to 127, this is all same, identical. Whatever the ASCII chart, if you take ASCII chart, 0 to 127 will be standard set. Okay, now if you look at this, 0, SSNUL, SOH, STX, all these weird things, okay, these are actually known as control characters, okay, these can't be straight away printed on the screen. These are for controlling purpose, so we will not look into it too much, except for few characters maybe. So 0 to 31, that's what we are saying, ASCII control character sets range from 0 to 31, that is from here to here. So these are the binary representation of that, okay. These are all control characters. This plus, there is one more character at the end, which is 127, which is this one, 127. It's a delete. It's not a printable character, okay. It's a delete operation. So these are control characters. So 0 to 30, 31 plus the 127 are control characters. But from 32 to 126 are the actual printable characters that you see on the keyboard and what we deal with in our day-to-day life in the systems. Okay, so 128 to 255 will be some extra sets. So that's why I didn't put this mapping and show you what is 128, 129, 126, because it will differ depending on the mapping that you are seeing. So if you like, you can go to the web and find out about this extended ASCII set. Okay, it goes from 128 to 255. Why 255? Because when you have 8 ones, it's 255. That will be the last number in a 8-bit possible. So 128 is 1 and 7 zeros, and then last number will be 255, which will be 8 ones. Okay, so if you look at this, I want to pay a few attention to some of these characters. Now look at 32. 32 is binary like this. Okay, 1, 2, 4, 8, 16, 32. See, 1 in the 32 position. This is actually space. So remember, even a space, even though it's blank, nothing comes. As far as ASCII is concerned, it has a value. Okay, and the value is 32. 32 means space. In ASCII, okay, I'm not talking about binary numbers. In ASCII, when you interpret this as a ASCII number, 32 means a space. 33, as you can see, 33 is exclamation mark. 34 is, I think, single quotes or something. 35 hash. 36 dollar sign. 37 percentage sign. 38 ampersand sign. Like that, open bracket, close bracket, multiplication sign, single quote, addition sign, division sign, minus, plus, all this. Plus, remember, even for numbers, 0, 1, 2, 3, 4, up to 9, you have ASCII values. Going from 48 to 57 are actual digits that we are dealing with. So now you're going to ask me, then what about binary 0? What about binary 1? We'll come to that in a minute. Okay. So in terms of ASCII, if you're talking about ASCII 0, it's represented by 48. Okay, space 32. The binary equivalent is this. Okay, this is how it will be in the byte memory. So I just showed you the binary value as well as the decimal value to understand. Okay, so 48 to 57 will be 0 to 9. Then you can see colon, semicolon, less than sign, equal, greater than sign, question mark, at sign, and capital A. Capital A is represented by 65 by ASCII value. ASCII value 65 means it's capital A. ASCII value 66 is B. Like that, it goes up to ASCII value 90. Okay, for the 26 letters A to Z, all the capital letters go from 65 to 90. Then you have open square brackets, the backslash, the square brackets, and tilde and underscore, so many things. And then 97 is the simple A. So see, even A and capital A and capital simple A, have different ASCII codes. So if it is 65, it will be capital A. If it is 97, it will be simple A. So 97 to I think 122, right? Up to 122 is the simple letters of alphabets. Then you have some other things like the brackets and so on up to 126. So actually characters that we are going to be dealing with really are 32 to 126. Okay, and these characters are shown here, what character that this particular ASCII number represents. Okay, shown in decimal as well as in binary. Now if you look at the control characters, there's just two characters I want to talk about. One is 10, which is line feed. The 13 is carriage return. Now, if you remember old typewriter, you keep typing, and then you go to the end of the typewriter, and then what do? You hold that carriage return and push it back to the beginning, and that will advance the page by one line. That is the purpose of this carriage return. Carriage return is once you are at the end to come to the beginning. Line feed is to skip one line so that you go to the next line. So this line feed and carriage return means come to the beginning and do a line feed so that you go to the next line. So that is why if you now in Notepad, when you have some characters, you type in all those ASCII values you see. When you press enter, the return key or the enter key, internally it will put a line feed and a carriage return. But these are control characters. No, that is why in the Notepad you won't see it. But those characters are there in the file, in the text. Okay, you don't see, and because of the carriage return and line feed are there, only the next part comes in the next line, beginning of the next line, and at the end of every line in our Notepad there is a carriage return and a line feed which we don't see. So like that, there are other control characters also. These are used for various other purposes inside. Okay, so don't worry too much about this. You can maybe Google it and just get some more information if you want to. But our main concerns will be 32 to 126. Especially what we will be really considering are the 0 to 9, that is 48 to 57 plus 65 to Z, those are the alphabets, capital letters, then the simple letters. Okay, these are what ASCII table means. So you can refer to this to just get an understanding of what those characters are, and we will be able to see these in our when we get into actual programming, and when we start to do coding, we will be able to understand these characters and see them. Okay, so what you have to remember is ASCII characters are 7 digits going from 0 to 127, and since computer memory is byte wise, it goes 8 bits are there, so they have used that extended ASCII chart to represent the other characters from 128 to 255, and that is not a standard set, and there are multiple sets available between that. This is the standard one, 0 to 127, and out of the standard one, 0 to 31 and 127 are control characters. So they can't be just printed or seen on the screen. Okay, the characters you will be able to see will start from 32, which is a space. Actually, even that you won't be able to see, but there will be a space available. Now, for example, if you write the computer, you will type THE, and there will be a space, and then computer. So that space will be represented by 32. Okay, so that's that, and all these other characters will be there. So, but basically, what I'm trying to tell you is, even though it is a coding system or whatever that we are using, what is stored in the computer's memory, even for characters, is zeros and ones. So, in the computer memory, there is nothing else possible. This is what is actually recorded. And let's see then. So now we have an issue. What is the issue? Now this, if you take, let's take A, capital A, we know, which is 65, right? 65 means 1 here and 1 here. That is 64 plus 1, 65. Is capital A, if you take it as ASCII. But this can also be 65 number. So how does that happen? How is it possible? So let's see that. So